us say pay by cash. So it is saying 10 epochs and 5 batches. This is the final. Then it's time to predict our output.
Chatbot using NLP and machine learning.
First of all, when discussing about chatbot, what is chatbot? When our user want to get the information automatically from a server, like if you type, I want to know about the products you are selling in your shop, like that, we have to get the output there without human interference. So this kind of response we can expect from the chatbot. Let's make a simple chatbot that is user friendly with giving the information which is required for the user by using simple question and answers type. So starting from the user, if user asks something like hi, generally our user starts with greeting the chatbot, right? Hi, hello, good morning, something like that. We can say these are the greetings. So all this hi, hello, good morning, good afternoon, this kind of wishes comes under greetings tag, right? And user might require some information about some products or the shopping items or eatables, anything. So user may ask what kind of what kind of products you have. So this is a kind of information seeking tag or category tag. How many products we are selling in this category, something like that. So what our chatbot does is it will take the question that is provided by the user, what kind of products you have, and it will pre-process that question and it will tag it to the appropriate class, then give the response correspondingly. So this is the flow, guys. User will give the input, user input. You think it might a conversation, question, or a sentence. This will be taken by chatbot and it will connect with the machine learning model that we have created, that we will be creating in this video. Then it will tag to the appropriate class, tag into the class, and it will give the response, giving back response. This is the flow, guys. So you can ask me where is NLP in this flow. You're only saying about the model. So coming to the NLP, here comes the thing where you can see the model is trained on only numbers, not the sentences. So here comes the NLP part, where it will try to convert the sentences into the numeric form. Like there are some steps in NLP to convert them into numbers vector form. Let me explain a simple steps that we are being used in this process. Let's discuss some steps in NLP. Step 1, we'll take the input from the user. Let's consider this sentence, what kind of products you have. You should take this sentence. This is a questioning. We will take this sentence. Second step is to tokenize them. Tokenizing in the sense we have to break the sentence into different words. So here the words are what, comma kind, comma of, comma products, comma you, comma have. And we should not forget that question mark also. These are all the different kinds of words. This is the tokenizing part. Tokenize. And the next step is to limitize the words. It is called limitization, in which we'll convert all the verb forms of the words into the main form. Like for what it is what, for kind it is kind, and of it is of. For products it is single, it is plural, so we can convert them to singular product. And for you it is you, and for have it is have. And at last question mark. This process is called limitizing. Limitize. And next step. And in next step we have to remove all the stop words. Stop words in the sense like question mark, the exclamatory marks, and hyphens, underscore, any other special characters. We have to remove all of them. And also the simple words like of, is, the, we can also remove all of them, which is having lesser effect on the sentence because these are regularly used and maybe will come under every sentence. So it is common, we can remove them. So after removing this kind of stop words, our sentence becomes like this: what kind of product you have. After removing stop words, so we have to make a vector out of these words now. The next step is to convert them to the numeric form. Before that, let's consider the output here. We have different classes here, like greeting. Greeting is one class, and category is one class. These are the outputs we have to tag to, and some of the responses will be triggered after we are tagging to these classes. Let's take only two classes here, the greetings and the category. So if we convert them to the numeric form, it will be, for greetings it is 1 comma 0, and for category it is 0 comma 1. I'm just considering it as 2 0 1 values here. If the first index value of the array is 1 and everything else is 0, then it is greetings tag. And if the first index is 1 and every other position is 0, it is category. Now we have to convert these words into the vector form, that is the bag of words. Before Now we have to convert the words into vector form, that is the numeric form. Before that, we have to find the bag of words we should be using in training the model. Let's find the bag of words. Bag of words. So we already took a hi, hello, good morning, and what kind of words we have. These two sentences here. Let's take one more sentence. Mm, what are the opening hours? Like the shop timing. You can say it as timings. So if you take the bag of words, let me tell you what is bag of words. Bag of words in the sense we have to take all the words in the sentences that are being trained, and we have to tokenize them, lemtize them. Then we have to remove the stop words. The remaining words which are present in the list is called bag of words. So if we consider these three sentences, the bag of words for them are what, or is the stopping words. So we remove the or and the, and opening, for opening the lemmatized word will be the open. For hours it is hour, and for hi it is hi, and hello, good, comma morning, comma kind, because what is already being taken. You have to take the unique words only. For products, we take product, we remove the off here, and you, comma have. So these are the bag of words here. So these are the bag of words here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 unique bag of words. So we'll take an array with, and so on, 11 elements in it, because the output should be, because if you consider these 11 elements, we should use this bag of words. Because if you consider these 11 elements, we should use this bag of words to tag the sentences to the corresponding ones and zeros. Let me explain you. If you consider the sentence, what kind of products you have. Until step 5, we have removed all the stop words, we tokenized, lemmatized, we removed all the stop words. We have done all these steps. And at last step, we have to compare the sentence with the bag of words, and we have to give the array. We have to give the array representation for this sentence. Like, if this is the sentence, let me take an array value. Like, if these are the bag of words, let me take the array value for this bag of words. Let's take all zeros. 0, comma 0, comma 0, comma 0, comma 0, comma. Now I have taken all 0 values. Those are 11 unique elements. If you consider the same array here, like copy this whole array, let me copy it. If I take this array, You can see, let's see how I convert the sentence into numeric form using this bag of words array. Consider what. So what is present in bag of words? Yes, it is present. So the first index is, the zeroth index is 1 because it is present in the bag of words. And open, whether open is present in our sentence? No, right? So it is 0. And the next is hover. Hover is present in our sentence? No, it is 0. And next is high, it is not present, it is 0. And hello, it is not present, 0. And good, it is not present, it is 0. And morning, it is not present, it is 0. The same way we have to fill all the array values here. And kind is present in the sentence, so we can make it as 1. And product is present in the sentence, we can make it as 1. And you, it is present. And have, it is present. So this is the final vector of our sentence. So the input sentence in numeric vector form is already there here, this array. And if you consider the class for this sentence, like we have defined here, the greetings and category, it comes under category. So the output for this sentence is vector 0 comma 1, which is nothing but category. So under this category, we will be defining some responses like popular products P1, P2, P3, and so on, and popular brands like B1, B2, B3, all these products and brands are available in our store. So these kind of responses, you can use the first kind of response or the second kind of response. Any response you need, you can randomly send these responses which is tagged to this category, right? So this is the overall flow of our chatbot. Let's recap this again. We'll giving the input to the user. Let's recap this again. We'll be taking the input from the user. That is chatbot is taking the input from the user, and we'll be tokenizing the sentence and lemmatizing it, then removing the stop words, and then we'll use a bag of words that is there in the training data set, and we will convert the sentence into vector form. Then using our model, it will predict the class which the sentence comes under, and accordingly we will send the responses using the predicted class. Let's discuss all of this in the coding part. Before that, we need the training data, right? So for training data, we have to consider some raw data. This is the JSON file where I have created a few patterns, tags, and their corresponding responses here. So the user might type any of these patterns, and they will get pre-processed, and model will predict any of one of these tags, that is output classes. Then any one of these responses will be given to the user. So that's how it works. So I create a simple JSON file here for greeting and saying goodbye and wishing kind of things, and some options to provide the user some information when he asks for any help, and some category items here, some shoe tags and also pan tags, and the hours, like how many hours the store gets open, and the payment, how can we pay the bill. If user has any of these queries, he can ask. I simply took very few tags and classes here, so I can show you the example how it works. Let's see the program now. So this is the program. Here in the first step, we have imported all the required libraries required for NLP steps and also the machine learning part. First step, we imported the JSON file indents. So you can see the patterns, responses, and all the tags here in dictionary form. And then I took each of the patterns, that is the patterns. What I'm trying to do here is I'm trying to make a document where it will make each sentence into the separate array of words, and along with that it will be tagged to the its classes. Here I have defined in this JSON file. As you see here, this is the document I'm creating. So for how you could help me, the tag for it is options. So how it is tagged like that. So it is tagged to options classes. Like that I have made a for loop here and made a document. And also I listed out all the classes here, like greeting, goodbye, thanks, options, list items, category 1, category 2, shoes, pant, hours, payment, kind of things. So as we discussed, we have performed our first step tokenizing here. So these are the words. that are being tokenized. These are the sentences that are being tokenized. Now the next step is to limitize them. Here I'm using limitize function to limitize all the words, and in the same step I am ignoring the stop words. So I have defined this ignore words here. We can add as many as like off on the every ignored words here in this list, and then they can be ignored in this list while making this list. So now I have documents, classes, and the unique limitized words because I have used set and then sorted them out. Then I will be remained with only the unique words that are being used in the training data. Let's see how many words are there. If I can see here, there are 88 unique limitized words. So these are the words that I'm talking about, the bag of words. I have shown it in the example, right? The bag of words. These are the same bag of words that are being used in the training data. So let me make some training data with numerical values using the sentences. Here what I'm doing is I'm taking the words from the sentences and I'm checking whether they are present in this bag of words or not. If they are present, accordingly I'm taking the input, and corresponding output is nothing but the classes we have defined, like the categories you have seen here, the greetings, goodbye, thanks options. I have made like there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different types of classes here. So I have taken output array with the length of classes we have, as I shown in the example here, right? Here I took two arrays, right? See, greetings, categories. Here I took two arrays, 1, 0 for greeting and 0, 1 for category. As the same way, I have 12 classes now. So I will be taking 12 arrays with different kind of 1 zeros. For first place, it is greetings. For second place, it is category, like that. I will be taking for first place, it is greetings here as well. And for second place, it is goodbye. And the next place is for thanks. Like that, every portion of that one has a different meaning. It is tagged to different classes. Coming to the bag of words here, these are the bag of words. So we'll be creating 88 length array like this in the here, like it is having 11 unique elements. So we have created an array with 11 unique elements, and we have done our calculations here. In the step 6, we compare the bag of words with the sentence here, and created a we derived an array out of the sentence. So that's how we converted the sentence into numeric form. That's how we convert the sentence into numeric form in the coding part also, using the bag of words. After converting them to the numeric form, let's say it is hi there. Hi there is nothing but only two words. So you can say that there will be two ones in the list of 88 unique bag of words, right? So there are only two ones. One is here for hi and one is here for there. It is that simple. So output is tagged to position 4. Position 4 is greetings here. You can see the greetings I'm printing here. And then we will be doing the same thing with every sentence. We'll be comparing it with the bag of words and making an array out of it, both input array and the output array. So that's how our training data gets ready. From this whole data, I will be taking some X data and Y data. Y data is nothing but the output words, and X data is nothing but our training bag of words, the list of sentences that are tagged to the bag of words and converted them to the numeric form, right? Those things are our input to the model, and output is the classes like greetings, shoe, pant, house, payments, everything. And I have created a sequential model here, neural network, with three layers, three dense layers. And in first layer, I have taken 128 neurons. And in second layer, I have taken 64 neurons. And at last, I have taken the neurons length as same as the classes length, because I have to get the probability of each classes. Then I will be taking the highest probability value as an output. So I have trained this model here using 210 epochs and 5 batches. After training, I have saved the model as chatbot model 1.h5. Then it's time to predict our output. I have imported all the required things like the model which I have saved earlier, and loaded the intents and votes and classes I have saved earlier. Before that prediction, let me create two. Before the prediction, I have created two functions here to make our predictions easy. So I created a function predict intent. Here I'm sending a sentence. Let's say it is a user input and the model. So, and a bag of words. It will convert our sentence into a bag of words, as I said earlier, and then it will return the bag of words with an array, and it will send it to the model. It will give us the prediction. In the prediction, we have to sort the prediction values Accordingly, the highest one comes first. Then I will be returning the first sorted element classes as an output. So let me check. I have, I have given a statement here, pay by cash. So what kind of statement it is? You can say it is recording payments, right? So if I give that, it goes under, these are the classes, list of classes, and these are the predicted probabilities here. For zero category, for zero index category, it is 0.002. Like that, I have sorted them out. This is the output with a category and probability. After sorting, the ninth position element is having the highest probability. That is nothing but payments. So it is having 0.89% probability. So I took payments as an output here. After getting the payments class, we have to respond to the user's message, right? So as you seen in the dictionary, in the JSON file, we have responses. We have responses here. So we will be returning any one of these responses by using the output tag that we got there. For payments, let's say for payments, we have two responses here. Randomly, we'll be sending one responses. So that's it. So this is the function where I make that response. So this is the function where I make the response sent to the user randomly. I use the intent, and for intent, random choice. Ran for intent, random dot choice of responses. So I'll get only one response. Then I'll break out of the loop and then return the response. This is the sample conversation between me and the chatbot model I have created. I said hi, it is a greeting. The probability is 99%. So it said, hi there, how can I help? I said, I want to buy some shoes. Shoes is the intent. Shoes is the intent here. It is for 99% probability. And its response is showing the requested shoe module like that. And I've given credit card here. The credit card is recording payments, right? So it is payments and it is 98% accuracy. Here it said we accept most major credit cards like that. Here it is buy and it is goodbye category. So it's saying response as have a nice day like that. So this is the program I have created using NLP and machine learning. But wait a second, I have created an UI for it also. In no time, I will be showing the UI now. So I created the UI using HTML files and static CSS files with one small JavaScript file and Flask in the backend as a server to route between the two HTML files. This is the same code I have used in the Jupyter notebook, but pasted in this GUI.py file. But I have used Flask routes here, so it will route them to the corresponding HTML files. I just created a simple form here to take input from the user and give a response from the server by using the model I have created. So let's run this file. Let's check it on the UI. It started now. It will show some warnings kind of things if you don't have GPU mission. So ignore those warnings. It is running on this port. It is running on this port. Let's copy and paste it here. So this is a simple UI I have created for chatbot, but we can improve it and you can add it to any of the websites you wish. Accordingly, you can change the intents.json file to get the responses. That's it. Let's run it first. I said hi. So I have given three responses for it, right? So it is randomly selecting one response and sending it here. So just say, let's say hello. Yeah, it said hi there. How can I help? Let's say I want to buy shoes, showing two requested brands of shoe. So like that, it is giving response. And let's say I have given the order, right? Let's say pay by cash, pay by cash. So it is saying that we accept Visa, Mastercard, and MX like that. But I think it will not accept cash. So yeah, we got the required information, and let's say goodbye. Bye. See you. Yeah, that's it for the basic chatbot. You can integrate it with any of your choice websites. That's it for the video. If you like the video and understood it, If you want more videos like this, subscribe, like, and share. If you have any doubts, comment it down. Please, guys.